Rivers have been dumping dissolved minerals into the ocean for billions of years. Sodium, chloride, and more, the very building blocks of salt. So why isn't the sea getting saltier every single day? To answer that, we need to follow salt on its journey from rain to rock to river to sea. And surprisingly, the story doesn't start in the ocean, it starts with rain. Rain falls, picks up a little carbon dioxide and turns slightly acidic. When it hits the ground, it slowly eats away at rock, chemical weathering. Over millions of years, that pulls ions out of rock: sodium, calcium, magnesium. Chloride joins in too from weathering, volcanoes, and hydrothermal vents. Groundwater and rivers carry it all downstream. Sodium and chloride are the big players. Together, they make up most of the salt in the sea. But here's the thing. Rivers aren't carrying grains of table salt. Sodium and chloride travel separately as charged particles. Rivers deliver the ingredients, not the salt itself. The sun hits the ocean. Water evaporates, rises as vapor, forms clouds, falls back down as rain. But the salt doesn't go with it. The water leaves, the salt stays behind. That's the real reason the ocean is salty. And here's a detail worth passing on. Rivers carry minerals too, but river water isn't salty because it never sits still. It keeps moving straight through to the sea, so nothing builds up. Lakes usually work the same way. Most have an outlet, so minerals flow back out. The ocean has no outlet like that. Almost all its water leaves through evaporation alone, just water. The salt has nowhere to go, so the ocean becomes a giant collection basin, which raises an uncomfortable question. If salt keeps pouring in and only water leaves, shouldn't the ocean just keep getting saltier forever? Here's the twist, it doesn't. The open ocean has held steady at about 3.5 salinity. Why? Because salt isn't a one-way trip. Some dissolved ions react with other substances and turn solid, settling into the seafloor. Marine life pulls salt out too. Corals and clams grab calcium and carbonate to build shells, and that becomes part of the seafloor when they die. In places with intense evaporation, minerals crystallize into rock salt, and deep underwater, hydrothermal vents constantly trade chemicals with the crust below. So, the ocean isn't just taking salt in, it's letting salt out too. These two processes don't have to match up perfectly minute to minute, but stretched out over billions of years, they land in a dynamic equilibrium. Salt in, salt out, and the average holds roughly steady. Try to picture this. If you pulled every gram of dissolved salt out of every ocean on Earth and spread it evenly across all the continents, it would bury them under a layer of 150 meters thick, about 500 feet, a 40-story building of salt everywhere. And every bit of it is the product of one massive planet-scale cycle. Rain, rock, rivers, evaporation, geology, and life working together for billions of years. So, why is the sea salty? The ocean isn't just a bucket that's been filling up for 4 billion years. It's a cycle, a planet-sized one, constantly gaining salt, constantly losing salt, holding steady somewhere in the middle. So, next time you taste salt in seawater, remember what you are actually tasting. A tiny trace of a journey that started with rain falling on ancient rock and has been circling this planet ever since. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.